Hey everyone, welcome in to another daily editorial here on the KE Report. I'm getting an update from Graphene Manufacturing Group, traded on the TSX Venture Exchange under the symbol GMG. I am chatting again with the founder and CEO, Craig Nicol. Now, in this interview, Craig and I are going to go through a number of questions that you all sent in to me. I know it's been a couple months since I last had Craig on the show, but I'm going to be bringing him on more regularly, pretty much every month, to keep addressing all the questions that have come in because, boy, oh boy, I sure get a lot of them, and I appreciate all of you sending me your questions. I have these questions isolated in terms of the graphene production side of the business, battery technology questions, as well as thermal XR, and a couple other questions mixed in there. So, Craig, let's get right into it. On the graphene production side of things, I had a couple listeners email me asking for graphene data sheets. If the company is going to produce a graphene data sheet, let's start high level. What is a graphene data sheet, and is the company going to produce one for us?
Hey, thanks, Cory. Thanks for having me back on. Always good to be here with you. Certainly, we used to have graphene data sheets back in 2018, kind of 2019, when we were selling the graphene. We used to talk about our graphene quite long, in quite detailed amount of information with our customers and potential customers. Of course, our business now has changed, where we sell a graphene to ourselves, and then we put that into our own products, and then we look to sell those products that have our graphene in it. So it is less important. But in saying that, though, because what we're after is an effect that the graphene gives to our customers, not necessarily the precise graphene. And we manage the graphene spec to ourselves. And so we have our internal graphene specification, which we've worked out some time ago on most of our products. And then with our batteries, we've kind of working it out. We're getting much closer to finalizing that exact which one is the best. So there's a bit of history there. We have had our graphene analyzed by different universities in Australia and also in other parts of the world, and they have said yes, it is graphene. It is good graphene, very high quality graphene. And so I guess it's the point of, what do people want to see? What's the outcome they want to see? I think if you did want to see our information more on this, I think it's best to probably jump on our website and put it into our contact sheet, and we can probably share some information. But it really is something that 99.9% of people don't necessarily understand straight away. We talk about number of atoms high. We talk about the percentage of our carbon, a percentage of oxygen, which is very little to nil because we don't have any oxygen in our process. We talk about contamination. We talk about carbon ring size and width of platelet and shape of platelet. So there's a number of things, and we talk about bulk density, how many grams of graphene do fit per liter generally is the sizing. So there's a few things like that, and then we have some transmitting electron microscope photos, images, and also some Raman, which is a characterization of how many graphene layers there are and the defects involved. And then we'd also put in a scanning electron microscope. So we used a microscope image, which is it's like a photo of the carbon with an electron beam. So we used to do that externally. We now do that internally, and we don't really hand that information out because it's just not needed.
Yeah, Craig, and I think to this point, a lot of people are wondering, can you produce enough of the graphene you need to satisfy a growing battery division here? How scalable is the graphene? I know we have touched on this before. And if you did need to go to outside sources for graphene, do other sources provide the type of graphene that you need?
Yeah, so all very good questions and questions that we continually ask ourselves. We're continually pushing ourselves on every one of those points. So obviously we're building our expansion project, which is we're aiming to have it ready by the end of June, which we've took an investment decision on that somewhat halfway through last year. So that brings over manufacturing system across a complete new whole lot more control with automatic sensors and control algorithms that will enable it to jump to that high level performance. And then there's a range of other things that we put into this that means that we can expand it a lot faster because we put in all the infrastructure for a much bigger plant. Now, that project is the first thing that's supposed to happen this year to enable us to jump to the next level of graphene quality. With our graphene for TXR and for graphene lubricants, there's very little graphene we put into those liquids that does the work. So it's a much lower percentage. So that kind of graphene production is probably easier to see how we could make that product. And it's also a particular type of graphene that we find a bit easier to make as well. We make it a bit faster. Now, the type of graphene we need for batteries, that's a different graphene setting, and with the same equipment though. And that one, we are always looking at other graphenes that we could use around the world. Now, we generally can't use graphene oxide, so that's mean 95% of graphene production in the world probably won't work very well. We need to use graphene, which is just carbon only, like ours. And there's only a few of those out there. We've tried a number of them, and there's some that are okay, some that we need to do more work on. We could get them there, but it is part and parcel of the battery is that we need a good graphene to make this happen. And so we continue to work in that space as a battery developer. We're also looking at alternative graphene supplies just in case we need to make a lot more batteries than our graphene is currently sized for. And we'll continue to do that. We'll continue to look at it both as a graphene supplier and also and battery developers and review it on that basis. It's not exclusive that you could only use our graphene. It could be used for others, but you will get probably a different battery outcome. And then you need to understand that, and you need to be cognizant of the differences that it will make for the battery and then what could affect the customer's applications. So that's the biggest point, that you need to be able to engineer those differences into the end application and the customer can be happy with it once you've actually started using somebody else's as well. But right now, we don't expect to use it. We've just done some planning workshops. We don't expect to get a third-party graphene. We should be able to use our own graphene for some time, even with our build-up, which is obviously we're building as we're building the projects as well for the graphene production. But we're just to be clear, though, we are fully aware that we need to be accounting for making more batteries potentially than we have graphene at the same time. So that's what we continue to look at as well.
Okay. Craig, we're going to move on from this aspect of it, but for everybody who still has questions here, please send those in. Now, when it comes to how you make your own graphene, you've mentioned that you use about 10% of the carbon from natural gas to produce the graphene. Can you take us through this process again? And hopefully that'll answer some of the questions, and I'll come back to you with a couple others then.
Sure. So obviously with this, we hold a trade secret around the process. And that's quite important to maintain for the company's future. No, it's not the only thing we have now. We obviously got other products and technologies, and as a business, we're more than that as well. But we do need to maintain that trade secret focus. So I'll only talk about it to the point that makes sense, but I won't show any IP around this. So obviously, I gave a 10% number in the past because that's what you could say is how much we use. We actually use different numbers depending on different graphenes, and because we're actually we're solving this equation for the graphene quality, not necessarily the amount of graphene conversion. And then it's around how do you manage that feedstock for carbon, which we're also working on for scale up, because that's obviously quite important to be able to get access to carbon atoms at a grand scale, so that you can. We can really scale in the future as and when, hopefully we need to for our customer demand. So first of all, 10% is a number, and it's a reasonable approximation, but it's not only 10%, there are other numbers. And what we do then with that gas is we do two things. We've had an R&D facility where we put that back into the generators, which have obviously part hydrogen, part methane, and then we use that to then power our process, our plasmas, as well as other bits of the plant as well. But when that is not available, we do vent. Now we've got a program to basically make that clear that we stop venting in our production process as much as possible, and we go straight to just taking it all into our engineering, our engines, our gas engines. So we basically use the hydrogen in the engine because we're going to a production mode now. That's obviously very important. So the R&D facility that we've had has that ability to be able to take into the engines or not up to vent, and there's a whole lot of hydrogen in that. So that's obviously one part of the process we're moving towards in the production, and we're having, as we've announced, a part of that is a microgrid, whether it's batteries, solar, and a combination of hydrogen, gas, power generation that will be blended into battery storage, which will then be able to manage the energy we use in our plant better. Currently, we just use solar and some hydrogen, and grid and that in an R&D facility. So we're going to a new grander scale, which is going to be bringing it all together in a much more controlled fashion. And then when the graphene is then pulled out, we'll then have the ability to obviously then take that away and move that into our next stage process for the company, either a battery, energy saving coating, or energy saving lubricants, graphene lubricants. So I think that answers the question.
So it really sounds like this is still a learning process for you guys too, in terms of how much you scale, and you're scaling the hydrogen or the graphene production with all the other things that are happening, especially in the battery division. Is that fair to say?
Well, the graphene plant has been up and running since 5 years now, and we've been running it 2 shifts generally for 5 days a week with production operators probably since 2018 or so, 2019, on multiple units. What I'm talking about there is putting more pipes and equipment to be able to receipt and then use that energy on a more controlled way. So I don't think it's necessarily learnings, it's more putting it into a grander kind of scheme that can produce more graphene in a controlled way. With obviously what we want to get to is basically a negative business, negative in terms of emissions. So I think that that's the plan, and that's what our projects team is focused on delivering. But what we need to do at scale work out how we access very large amount of gas and at low cost. That's what I'm talking about. And so that's a part of building a list of partners that we can work with who can actually give us a load of carbon atoms in methane. And then how do we then manage that hydrogen at the end? Because that is a very valuable product, especially at large scale, especially for batteries. So that's why we're also broadening out this year and making sure we include some potential partners to run that to ground.
The last question on the graphene production. I heard that the company has withdrawn the patent application for the graphene production method. Is this the case? And if it is, how do you prevent copycats from coming in here?
Yeah, so it's why I touched on the start of the call around trade secret. We're very focused on the trade secret being the way we manage our IP for that. And we initially launched under a confidential application to the patent office, a patent for our process, which we knew we had good clearance on from what we had seen. And then after we had gone through a review process, we actually withdrew that application, and we've kept a trade secret protection of the IP process in place since. So which means that it's a very kind of careful and deliberate way of managing our IP. If we do a patent for a process, it becomes available for everybody to copy and then us to be able to enforce it. And it's quite difficult to enforce in someone's plant anywhere in the world. They could use it, and then we would have to try to get and talk to them and tell them to cease, and we'd have to work out if they're actually using a process in the first place, which is very difficult to do without actually having some type of court action to be able to go and inspect their plant. So it's kind of well known that process patents don't really protect the processes, and that's why you've got a number of big companies out there who actually protect their processes through trade secret like we're doing, and not through patents. But with respect to the product, what we do though focus on is the patent process there. So where we put the graphene in and then we put that into a product, you can actually protect that a lot better. And so we are progressing the patent with the batteries. We are progressing the patent with the G lubricant, and we also have an early patent application in for heat transfer. So for heat transfer for the air conditioning coating, energy saving coating. So what that's called is a downstream patent fence, where you're protecting the process with the patent in the product, and then you're protecting the process with a trade secret. So you two multi-level IP protection, and it becomes quite powerful because the patent in the product refers to your process, which enables you to protect your process as well as your patent, as well as your product at the same time.
Huh. Okay, so it really filters down to the products. Again, I think it keeps coming
Yeah.
back to you're more than just a graphene production company. You're producing these products. So
Yes.
let's get into the battery division then. A couple questions came in on energy density. You said that the batteries through testing are already at par with current lithium ion batteries, but the batteries that GMG is making are only using one of the 3 aluminum electrons. Now, you've also made some comments that you're working on a next generation electrolyte, which then could use more of these electrons, 1 up to 3. Can you take us through what this means?
Yeah, so our battery is different with respect to a lithium battery on a few areas. One is most of our ions, electrons, come from our electrolyte, whereas in a lithium battery, which is the liquid that transfers the ion exchange in between the cathode and anode. But with lithium batteries, actually the ion can actually come from the cathode, and so hence and some from electrolyte. But you've got more than just the electrolyte. So our electrolyte is the only way to get the ions into the battery. And so how we put the ion into the battery is very important. And there's a number of ways we can put the aluminium ion in. Right now, we're using an aluminium chloride atom ion, and that is one way. There are other ways of doing that, and they produce different batteries and they produce different results. Currently, we're using only one electron, and that's off the aluminium chloride atom. But there are other ways we're doing more work on, which can enable multiple up to 3 electrons, and that is the path. That is the opportunity that this battery has. And it is sometimes you look at it and you can say, oh, I've got 30 years worth of development. So I just want to get my first product out, make it happen. And that's what we're trying to do. We're trying to push that out as fast as we can. And then the second product could be a completely different generation of electrolyte. And it might have different performance variations. It might be more energy dense, for instance, rather than a more power dense product. And that could continue for some time. That's the best way to describe it. The lithium-ion battery has been around for 30 years in production, and before that it was for 20 years or so. It's taken 50 years from concept to actually where we are now. And there was an enormous amount of development, and it's tripled, I think, at least in terms of energy density from where it was to where it is now. So I think there's some good metrics there. Well, we're not asking for 30 years, but that's where it could go. How and when those electrolytes get brought in is just an element of the future planning. What we're definitely working on is trying to get our first battery pulled together, and that's all about getting partners. And I can talk about that, but that's on another conversation. But that's all about getting partners developed with us and progress it as much as doing the deep engineering around the cell and pulling it all together to make it happen.
Okay, so I guess it's fair to say, because I know there's a lot more questions on this, even that I got, that it's just too early to answer what even is possible in terms of this. And in terms of pecking order, it really is just about getting the prototypes out first before even really aggressively going after this, I guess, increase in the electrons used.
Yeah, and that's what we're constantly doing, analyzing. Is there something else longer that could come in short term? And that's always possible. And there's some of these things are kind of more medium term. And are they possible to with the work they've done? Can they come forward? or are we still working with the current design that we believe is the best? And I think there's always that chance with this battery of turning the corner and seeing something a bit better, and we'll take that. That's definitely a possibility because we don't have to follow the lithium-ion battery process because it's already been done. So there's a lot of learnings we can take, and you bring in those learnings that can be very fast, and you can actually get some really good traction with that. But there are some things that we are doing which is also very new as well on top of that. So you couple that together, and that's why it's an interesting mix of let's get this done and let's work on that sidewise on the side and then try to bring it together. But yeah, I think you basically, when you boil the battery down, you've got your cathode engineering, your anode, which is quite simple, being an aluminium foil, a separator, which we're continuing to work out the best one for each different opportunity we're trying to drive, an electrolyte, which we just talked about, and then there's the obviously your casing and how you brought it all together. So those are the systems. That's the system we're in, and a lot of those are going to be very similar to a lithium-ion battery, but some of them aren't, and they need to be different because of the chemistry we have. And I think that's that's the electrolyte is in that space of which one can we bring first to farther for it to be better. And it's fair to say we're pretty much working on the initial electrolyte still, and we've got that one out there, and we're constantly seeing how we could potentially bring it in or not. And right now, what we've got right now is what we're working on.
Okay. Hey, you know what, Kike? Let's just say something to look forward to in terms of the development here, because it is still relatively early when you compare it to how long lithium-ion batteries have been around. On a more recent topic that people have sent me questions on, deals with the weight of the pouch cells. People were referring back to an investor report that was saying, oh, maybe these batteries are too heavy to be actually placed in EVs. Can you address this, please?
Yeah, so the battery pouch cells we started making them in quite earnest, and what we're obviously now working on is making them repeatable. And one of the phases of making it repeatable is to have an automatic stacking machine, which we've obviously just done an announcement yesterday on, which is part of the procurement program we did last year. Now that's progressing through the assessment phase of we've just done the initial factory acceptance. What that does is we make the pouch cells much faster, more accurate, and then you can get a lot better testing regime and get better data. So that's one thing we need to do to make sure we make a very good, consistent, multi-layer pouch cell. Pouch cells can come in single, but all the way up through to potentially even 40 to 50 layers of battery, as in anode and cathode, and separate in between. And when you get up to 40, 50 layers high, you need to really make sure that they're stacked properly. So the stacker really comes very, very much important to when you get up to that multi-layer. So we've got the equipment, we've got the the graphene, the tech, and we've got the people. We're just working through that phase. And obviously what we're trying to do is at the same time engineer where is this end application or application that this would likely end up in. So by the time we're there, we can actually get to an appropriate prototype. Now, when we've got appropriate prototype, I think that's when we could probably start talking about the mass of the battery. Before then, it's a bit premature. There's a whole lot of reasons that things could change from now until when we get to that appropriate prototype stage, where we've got it third-party tested and such things. But in all our data says so far that we shouldn't have a problem in where we're looking at with respect to lithium-ion batteries in terms of energy density, but in terms of our calculations that we've done off our coin cell work so far. So I think, I think it's just a bit early to say, but I don't think in any way should we think that we won't end in vehicles. I do have to say though, we aren't targeting mass vehicles up front. I just think that would be something we'd do after we've already worked with other, say, premium type customer applications that could work with us and get the real value out of the car instead of going straight to a high volume application, which I think eventually we will go into, but it will take further time to get to that.
Okay, yeah, it's a road that even gets you there, right? Let's touch on the March 6th news release. So just yesterday, it was the company's increased investment in this battery development center, this BDC. What are we talking about in terms of costs, in terms of what this money will do to help move forward this pouch pack?
Yeah, so this was part of the 600,000 Australian dollar investment we made last year, and we announced, and this is part of that investment, which enables us to go into pouch cell fabrication repeatability trials. Now, we've said that we're going to have it up and running by the end of the year. Obviously, that means that we want to have what we're aiming for is quite a good sample by the end of 2023. So, we've got some time up to make all that work, and obviously we're doing everything else in parallel. This is not a sequential type rollout plan. We're looking at manufacturability, we're looking at the customer applications and partnerships for supply chains all at the same time, because there's a lot of interest in this battery. I think it's fair to say. So, I think that's what we're looking at with this application. What it enables us to do is progress to a pouch cell. There's 95% of our customer inquiries that we've had inbound. We haven't had any outbound requests, so it's only companies coming in, potential customers, are with pouch cells. So this moves us into pouch cells in an automatic type fashion, which enables us to get more exact high-level stacking, which enables us to get repeatability, which is what we need. People need to see repeatable data. They need to see multiple battery cells all testing the same way, and this is what this is about. So it's a big step. I'm very happy that we've got here. I'm very excited because it really does jump us into the next level of battery cell producers. Obviously, still only at the laboratory stage, but it enables us to talk to some, hopefully some big customers who can actually see how they can work that in with their equipment.
Okay, we're going to get to who you could possibly work with. And one more question. Let's quickly move on. Thermal XR. Quick question in here is the business model around the Thermal XR. Have you thought about adapting it? Is there any chance that you could just get it in the hands of more companies so that they can start saving energy? They can save some money. You could maybe generate some revenue there. Talk to us about the business model around the Thermal XR division, please.
Yeah, so Thermal XR is going to continue to drive a lot of interest, both sideways and also forwards as well. I'll just explain sideways. So we're obviously focused on the HVAC industry, so the air conditioning industry, and that's been our focus for some time, on developing deep knowledge about how they're manufactured, how they're maintained, and what are the drivers around supply chains for that. So who really benefits with a reduced energy cost with their air conditioning? And really, it's the property owner. So how do you get to them? And there's a raft of people. There's consultants, there's HVAC contractors, there's building property managers, there's procurement people. And those are the conversations we're having still, but they're often now buttressed with a lot more data that we've had since December, which is showing our heat transfer rate that we can do. We can move heat faster in aluminium, at least 15%, which is, now we've got this great data set signed up by University of Queensland. So it's a lot of those conversations are now progressing faster because of that. The more data you have, the more sales and more progress you can make. But we're also we're looking at working through distributors through that sector and bringing them on. And some of them are coming to us, and some of them we're going to them. So that's really obviously good to see them progress. And obviously we're really focused on getting sales in that space. So that's the point around going deeper. But going sideways, there's a very clear space for this product to work in energy producing space, energy industry. So that includes the kind of liquefaction of LNG. That includes power generation, and we're doing some work there, which is also quite exciting as well. And so the full escarpment of range of businesses, markets that we could go after with this product is really still getting an understanding of, just in terms of its ability to change people's costs and the emissions that they have around energy. Now, what it means is that the scope for selling the TXR2 is much broader than we even really thought, and we was already very broad. I mean, every company in the world pretty much has an air conditioner slash heater. So now we're working through a process on saying, which of these is, in addition, more attractive, and which ones we can get maybe more traction as well, and top of with the HVAC, and going in deeper there. And so it's fair to say that's kind of where we are sitting, and it's definitely not for the faint heart, because you you do get on top of things, and then you realize you've got a whole range of other potential customers that you could get on top of. So what we're focused on is pushing through with the HVAC space. How we could look at other business models in other sectors is possible, but with HVAC space, it's a bit difficult to do other business models. That's a bit less interesting. What is interesting in other sectors where there's a lot more ability to innovate, and less people to say yes to new innovation, then there are business models that we could adapt. But we haven't really put much thought into it yet, because we're still working through a lot of the application proofing points.
All right, final question then, Craig. Deals with more of the financing that happened at the tail end of November, December. Company announced a bought deal of around, I believe, $5 million. A lot of questions came in saying, what's the company's roadmap here to bringing in a large, well-known company that could even be considered a partner in this development, that could bring in much more money to move everything forward? Can you just explain to us a little bit more in what stage you're at when it comes to attracting big investments from well-known companies?
Yeah, so we've got four major pieces of IP and revenue generating technology: the graphene production, the lubricant, the TXR, and the battery. And each one of them tends to attract a different type of person, a different type of company. So we're really trying to see if we can work with also companies that in one area, and then really kind of focus in on that area. So that's the first thing, is we do have a range of brilliant technologies that means that we've got a number of companies that are talking to us in that kind of space. But we need to be clear about which ones we want to roll out first, and why, and also, why that over another part of the business. And that's what we've been working on. We've announced at the end of last year that we'll be working through a range of potential battery customers. So whilst we're working on distributor partners for TXR, we're definitely working on also partners for battery customers, and really trying to get a broad partner that can come with us in use in many different ways. So that's an ongoing task. We get still a range of interesting big companies come to our website and want to talk to us weekly, and that's still trying to going through those opportunities, as well as the ones we have, as well as the ones we're in detailed discussions with. It's still an ongoing activity.
Okay, Craig, I do appreciate these updates. Look, I know this was a lot of questions that we went through, but as I said, I'm having you on next month, and we're going to address all the other questions that come in. And if any of you want more, I guess, information on any of these, please keep on sending me your emails. My email is fleck@kereport.com. In full disclosure, I am a shareholder of Graphene Manufacturing Group. And Craig, I think we'll be chatting again soon. So thank you for this update.